What is the Pythagorean theorem for decimals and fractions? Imagine trying to find the length of a diagonal in a rectangle where the sides are not whole numbers but decimals or fractions. How do you do that? That's where applying the Pythagorean theorem to decimals and fractions comes into play. The basic rule stays the same, but the way you work with the numbers changes a bit. The Pythagorean theorem says that in a right triangle, the square of the hypotenuse equals the sum of the squares of the other two sides. When the sides are decimals, you just square each decimal by multiplying it by itself. For example, if one side is 6.3 and the other is 8.1, you do 6.3 times 6.3, which gives you 39.69, and 8.1 times 8.1, which gives you 65.61. Then, you add those two results together to get 105.3. To find the hypotenuse, you take the square root of 105.3. Since the square root of a decimal often isn't a whole number, you can round it to a convenient decimal, like 10.26 if you want to round to the nearest hundredth. When working with fractions, the process is similar but involves a few extra steps. You square each fraction by squaring the numerator and the denominator separately. For example, if your sides are 1/2 and 3/4, you square them to get 1/4 and 9/16. To add these, find a common denominator, which is 16 in this case, so 1/4 becomes 4/16. Now, add 4/16 and 9/16 to get 13/16. To find the hypotenuse, you take the square root of 13/16. You can do this by taking the square root of the numerator and the denominator separately, which gives you the square root of 13 over the square root of 16. Since 16 is a perfect square, its square root is 4, but 13 is not a perfect square, so you can convert the fraction to a decimal for an approximate answer. Remember, the main idea is that the Pythagorean theorem works just as well with decimals and fractions as with whole numbers. The key is to handle the arithmetic carefully, especially when squaring and taking square roots. Using a calculator makes this easier and more accurate. This method is very useful in real-world situations like measuring distances in construction or navigation, where measurements are often not whole numbers. Whether you are working with decimals or fractions, the process remains consistent. Just convert, square, add, and then find the square root. This way, you can solve right triangle problems with any kind of number you encounter.